Hi everybody, this is Dr. Dinesh from Government First Grade College and PG Center, Chintamani. Today we will study the practicals related to a paper 502. So in this class we will study about the experiment number 4, Macrostate and Microstate. We will do this experiment with the help of dice. Unlike all the experiments, we will study the fourth experiment, that is macrostate and microstate experiment with the device. The aim of experiment is to show that the macrostate with maximum microstates is most probable. The dice experiment allows you to simulate through pairs of dice and see what is the result. Here we need an apparatus is that we need a 2 dice which is having 6 faces, and the formula used with this experiment is you are going to calculate the theoretical probability and experimental probability. The theoretical probability can be obtained by dividing the microstates with total number of microstates, and experimental probability can be obtained by knowing the number of events of a particular macrostate divided by total number of events. Here the macrostate is denoted by Ni and total number of events are denoted by N0. And after calculating the theoretical and experimental probability, you find the difference between them will gives me the uncertainty in finding the probability. And here the procedure is the point 1, roll the 2 dice together and add the total number of dots on the top face and put the tally mark near the number displayed in the chart, and repeat this process 500 times and denote that as N0. Count the number of times each number is obtained and denote that as Ni. Plot the bar chart of the experiment, then find the probability of that experiments in the form of a graph, and you plot a smooth curve of probability versus the frequency. Calculate the uncertainty of the probability and obtain the result of the uncertainty for the total number of 2, 3, 4, etc. The observations are the sum of numbers on the dice is denoted by macrostate and number of pairs on the dice is denoted as microstate. For this, let us take the 2 dice. One dice is having 6 faces which are denoted by the points 1, 2, 3, 4, 5, 6. Similarly, I am taking the other dice. With this dice, you are finding the total number of faces, that is 2, 3, 4, 5, 6 up to 12 faces will be there. For example, here you can see that there is a 6 plus 6 which is 12, and if I make like this 6 plus 3 is 9. The most probable possibilities are 2 to 12. Here is 1, here is 1, 1 plus 1 is 2. So here is 2, here is 1, 2 plus 1 is 3, like that you can do. And this is denoted by macrostate, and 1 here, 1 here, only 1 is possible, therefore that is the pairs of the device is possible is 1. And if I make 2 here in the one dice and 1 in the other dice, I can count that as 3, and this 3 is possible 2 times, like 2 1 or 2 1, 2 times it is possible, hence this microstate is 2. Like this, the microstates can be obtained are 1, 2, 3, 3 pairs are possible, 4 pairs are possible, 5, 6, and the probability of getting 8 will be like this: 6 plus 2, 5 plus 3, 4 plus 4, 3 plus 5, 2 plus 6, that is 5, and this probability is 4, 3, 2, 1. If you add all these microstate pairs, you will get total number is 36. And now 1 divided by 36 you mention in the table as theoretical probability, and this ratio will gives me 0.0278. Like this you divide and make a theoretical calculations. And how to obtain the experimental calculations? For experimental calculations, you throw the dice randomly at a similar same place. You are getting 5 plus 3 is 8. At the place of 8, I will plot 1. Next, I will throw it again. What I am getting? 5. Here is 5 plus 4, and you mark across that 9. And this is a tabular column which is showing me all the type of faces like 2. The probabilities you can get is 2, 3, 4, 5 up to 12. You make a column, and here when you throw a dice randomly, what is the number you are getting? So 2 plus 1 is 3. You put a line across that 3. Once if you get, if this line is completed, and for each box you mark the 5 numbers, like that you throw this dice up to 500 times. And this 500 times we did the experiment, and it has been obtained like this. Here when I throw that randomly, total number of throws we did is around 500 plus throws, 530 number we did, and in that one, so totally 547 throws when we did. Here when the throw is coming to 7 number is coming like this, 8 will be tabulated in the tabular column. Similarly 9, 10, 11, 12. Starting from 2 to 12, all of them are marked. This is the probable states you can get. And later you count all these things and you mention in a column. So this table shows the probabilities of getting the number of faces 2, 3, 4, 5, 6 like that up to 12. When the throws are doing, when you throw randomly, you will get 6 plus 2 is 8. Across 8 you put a mark. So when this mark is coming to be 5, you make a cross mark on that. Next, if 8 is coming, you continue randomly. So this is 6 plus 6 is 12. You mark at the 12 1. Next throw you are doing, if you do the throw again, you are doing 3 plus 2, it is 5. You mark across 5. Like this you throw for about 500 times. In this experiment we did the throws for 547 times, and we got a result like this. For 2 this times, that is 10 12 times. For 3 5 10 15 20 24 times. Like that all these things we obtained, which has been tabulated. Finally you add all this number of throws frequencies and you sum up all these things. So here 2 is coming to be 12, 3 24, 4 48. Like that you make a note. After making note of all these things, and you denote each of them as n2, n3, n4, etc., and all the added sum is denoted to be n0. n0 you got, you have n2. Now divide n2 by n0, you will get the probability of finding the 2 experimentally. It is coming to be, if you divide 12 divided by 457, it is coming to be 0.0219, and the third macrostate is obtained to be 0.0439. This is experimental one. Earlier we have calculated is the theoretical one. Now you are finding the experimental one. And after getting all the theoretical and experimental, do the differences. The differences are plotted. It is obtained to be the result. And here when the results you are getting, and that you tabulate, and they are coming to be, the sum is coming to be like this, 0.0059. So all these calculations are done, which are tabulated over here. Now you have a theoretical probability. You have to plot a graph. How to plot a graph? The obtaining a graph or a plot for variation of frequency of macrostate for two dice. Here for x-axis you plot a macrostate which is probably ranging from 2 to 12. 2 to 12, that is taken along the x-axis, and along y-axis you plot the frequency of a macrostate, that is denoted to be I. And here the number of probable states ranges from 2 to 12. So therefore the graph sheet can be divided into equal segments, which are 2 for every 2 centimeters, one macrostate I am going to increase, 2, 3, 4, 5, 6, like that. Along y-axis, the maximum probability of getting the states which are observed to be 86. So therefore I can take the scale along y-axis, which is total length will be fitted ranging from 0 to 100. So for every 2 centimeters, I am taking it as 10, 20, 30, 40, like that it is going to be increased. When you are plotting a graph that varies frequency versus macrostate, for first macrostate there are 12 frequencies, for second macrostate number 2. So therefore this is 5, 10, 11 and 12, 4 divisions above this line. This is the mark, you mark it there. Next, second one, that is the probability macrostate for third one will be 24. 24 can be plotted like this. For third macrostate you mark that as 10, 20, 4 means 8 divisions above. Like that you plot a points. So the points are plotted and they are obtained to be like this. So all the points are plotted. So it will be pointed as a points using a pencil. After getting that, you draw a smooth curve. Smooth curve indicate that if some point, the points are going away the line or below, never mind, the curve should not vary drastically, or there should be a smooth variations. So this is considered to be the smooth variation. You draw a smooth curve. Also you can draw a bar chart. So from here 1 centimeter left, 1 centimeter right, you draw a line across here. This will gives me the bar chart, and across here 1 centimeter to left or to the right, you draw a bar chart. Like this we have obtained a graph. We have plotted a graph, and also we have obtained the differences between the theoretical and the experimental probability, and that has obtained as a result. This is the experiment which is telling the macrostate and microstate with the help of dice, which is generally tells the behavior of the statistical behavior of the nature. So the curve obtained will be in the form of a Gaussian fitting. The curve obtained is considered to be Gaussian plot. Thank you.